Okay, so we are now recording. Carla, can you hear me?
Yeah, I'm here. I screenshotted it, so since I didn't get to write it down.
Okay, I went ahead and started recording this, and I'll go ahead
Okay.
and put that on the on my YouTube account. So I'm going
Thank
to go
you.
ahead. You're welcome. I'm going to go back and walk through this again. It's worth doing. So again, I didn't see any grouping symbols. So I see the radicals. I treat those as exponents. And as it turns out, they are exponents. This will blow your mind. Another way to write the square root of 16 is called with a rational exponent. That is, it is the same thing if I write 16 to the power of 1/2. Then that fraction, the denominator of that exponent, when it's a fraction like this, is the root. So actually, they are exponents in disguise. So anyway, evaluate square root of 16 is 4, square root of 100 is 10, and that is all I did. Then I went through and did the multiplications. The 2 times 4, the 4 times 10, and the 14 times 2 is 28. And then working left to right, I'm doing the addition and subtractions, and I'm just doing them one at a time. 2 plus 8 is 10, and that's all I did. And now I went 10 minus 8 is 2. And again, I just come on down. That's all I did. Now 2 plus 40 is 42 minus 28. And if you're doing this by hand, there's no shame in doing this. We got to borrow. And 12 minus 8 is 4, and 3 minus 2 is what? 14. And there is my final answer. Now, and you can also, and I have no issue if you use a calculator. And it is what it is because we're working online here. So every phone comes with a calculator, what I call a scientific calculator. And you're welcome to go ahead and use that. If we were taking a formal test in a classroom, I wouldn't allow the phone because it connects to the world and so on and so forth. But I would allow, I suggest what is called a TI-30XS because they're very cheap. They come about $15 and they look like this. Try to put it up to the screen. And it's the solar powered calculator, so you never have to buy batteries. Now, I do have an emulator, but unfortunately, site licenses, so many that I put on computers on the college, whether it's in the classrooms and down in the computer labs, and I don't have one loaded. That is, it's kind of exactly like this calculator that I can show. What I'm going to do is I unfortunately I'm not able to share multiple things at once. So I'm going to have to, but this won't go away. But I want to show you what's called a TI-84, a Texas Instruments 84 calculator. And so there we go. All right, so you should be able to see that calculator now. And it would. Okay. This happens from time to time. All right, give me 1 second. All right. Let me try the share again. Sometimes they don't talk well to one another. All right. Does everyone can see the calculator?
Yeah.
Okay. So you can actually do this with that real cheap one, the $15 TI-30XS calculator. The 84, I would not, unless you could, find a friend who would loan you one. These cost, even the 83s, which is a much older model, will run you about $100, brand new. The 84s, the brand new 84s, more like 120, 130. So unless you are going to take Math 126, college algebra, or Math 211, our statistics course, I would not invest in one. But the TI-30XS will do this as well. What makes them different than a scientific calculator works in what I call binary fashion. That is, when you do an operation, it is two at a time, and you just have to do each operation. On a graphing calculator, notice it doesn't have an equal button. It's got down here an enter button, and it enables you to actually type out the whole problem, and it already has programmed in the order of operations. So I'm going to do that. 2, that very problem we just did. Boy, I hope I get 14. That's my answer here. Minus 2. Now you just hit the multiplication. It comes up as notice kind of a dot. It's an asterisk, but it means multiplication. And then square root, which is a second function. So I hit the second button, and square root of 16 plus 4 times. And just like if you were writing it, if I don't write any symbol, if I don't hit multiplication, I just hit 4 and then hit the square root, it would assume multiplication. 100, close parenthesis, minus 14 times 2. So I just typed the whole thing out, left to right, just like we saw it. And I'm going to hit enter, and woohoo, I got 14. So lightning fast. But that TI-30XS calculator, the cheap one, it's called TI-30XS Multi-View. You can do exactly the same thing I just did. That is, type the whole thing out in a string, and it will do all the work for you. What I call the grungy arithmetic, and that's a wonderful tool to have, for sure, to check your work. But you want to make sure what's important here is understanding order of operations and how we worked them out to get to that answer of 14. All right, I'm going to stop share and call my whiteboard again. Okay. All right, and then there's a few what I would call application type problems, right? Real world type problems involving some arithmetic, but they're not ones you have to write an equation or name a variable. You just need to work through the arithmetic in each one. And let's see, what time is it here? So I think they're pretty straightforward, and there's nothing else. You should be able to work these out okay, but I'll certainly take questions on them on Tuesday, the Q&A, or even the beginning of class on Wednesday. All right. And then the other thing I wanted to get at, there will be another assignment 1.2, and here you're going to be working with the number line that we discussed. A number line is a visual representation of the set of real numbers. And we always, where does it start? The origin, which we call 0, and then we move positive to the right. But any number can fit on here. Negative to the left. And if I were to put pi, about 3.14, it's visually about right there. So any real number can fit on there. So you got a problem where you literally just plot some numbers on a number line. And then looking at some ordering. So always bear in mind on the number line, negative goes back in the opposite direction. That is, order reverses. So now, you're going to find this one to be a little bit challenging. I just put a number here, 368. And what I'm interested in doing is finding the factors of 368. All right, so what is it? What does that word mean, factors? So another word you can interchange with factors is divisors. Any number that divides evenly into 368. And when I say number, I mean a counting number. So remember the counting numbers, the natural numbers, 1, 2, 3, 4, 5, 6, 7, 8, dot, 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 onward and forward. So it's really, you're going to have to sit here and it's a process of finding all the numbers that will divide in there evenly. Now, bear in mind, as you go through and start this search, if you find one, you actually always find two, which means the list of factors always has to be an even number in terms of the number of them, because if you find one that divides evenly in there, then there will also be a number how many times it went. Now, the first pair of factors is really easy to find. We already discussed one is the multiplicative identity. One will divide evenly into any number that many times. That is, one is always a factor of any number. And the other pair is the number itself. So there's one. What is a rule to know if a number is divisible by 2? Pretty straightforward.
It's even.
It's even. So if it's an even number, figure out how many times 2 goes into it. Well, 2 will divide into 368 184 times. So there's another pair. All right. How can you determine if 3, to see if this one's a little bit more complicated, see if anybody knows this. What's the rule to determine if a number is divisible by 3, to check 3? See if anyone's ever.
3.
Okay, that's a good guess. It's not it,
9.
but it's a great guess, and simply because you're thinking about, if it's divisible by 2. So it's what I call reasonable. That's not it. So it's actually add the digits up of the number. In this case, 3, 6, and 8. 3 plus 6 is 9, and 9 plus 8 is 17. If that sum is divisible by 3, the number is divisible by 3. So I'm not going to even check 3. 3 won't go in there evenly if you punch it in your calculator. And I would use your calculator. I would just, once if I determine it's divisible by 3, go ahead, punch it in your calculator, 368 divided by 3. In this case, if you do that on your calculator, you're going to get a decimal number, which says it didn't go evenly. Since 17 is not divisible by 3. But that's the check. If you add the digits up and the sum of the digits, so that goes for any number. And that's crazy to think about, but it is true. If you add up the digits and the sum of those digits is divisible by 3, then the number itself is divisible by 3. So 3 doesn't work here. There is a test for 4, and it's not if the number's even. That only works for 2. The test for 4 is look at the last 2 digits, which is, in this case, 68. If the last 2 digits make a number that is divisible by 4, then the whole thing is divisible by 4. And let's see if this works out. 4 goes into 6 one time. Subtract, and that's a 2. Bring down the next number, and lo and behold, 4 goes into 8. What? 7 times. For 7, so it goes evenly. So that's the divisibility test for 4. If the last 2 digits make a number that is divisible by 4, the whole thing is divisible by 4. Now, you could easily just, because it just takes a couple seconds to take a number and punch 368 divided by 4 and see if it goes evenly. And in this case, it does. it's going to go 92 times. So, and a number divisible by 5 is if the ones digit is a 0 or 5, and that is not the case here, so it's not divisible by 5. 8, divisibility test is for me, it's just look at 2 and 4. If both 2 and 4 go into it, then 8 has to go into it. And in this case, 8 does. It's going to go 46 times. 9 works like 3. Add up all the digits. If that sum of the digits is divisible by 9, the whole thing is divisible by 9. 17 is not divisible by 9, so the number is not divisible by 9. 10, this number in is 0. Now, notice I skipped over. What number did I skip over in terms of divisibility? There was, as I went up the list, 2, 3, 4, 5. Oh, I didn't say 6. I should have. I apologize. For 6 to work, both 2 and 3 have to be factors. And since 3 wasn't, I knew 6 wasn't. But I did skip over one other number.
5.
Now, 5, I said 5 was the ones digit was a 0 or 5.
7.
7. It was 7. 7. Now, notice I worked all the way up to 10. So, kind of going back again real quick. 2 was there's a number even. So, is the ones digit an even digit? 3 was add up all the digits and is that sum evenly divisible by 3. 4 was the last two numbers evenly divisible by 8. Or excuse me, by 4. 5 was there's a number in 0 to 5. 6 is do both 2 and 3 divide into it evenly. 8 was are both 2 and 4 factors. 9 was can you add up all the digits and get something, a sum that's divisible by 9. And 10 was there's a number in 0. Next number is 11. 11 to me is, now there are some divisibility tests for 7 and 11, but they're so complicated, they're not worth your time to do. Just get your calculator and divide by 7, get your calculator, divide by 11. In this case, neither 7 nor 11 divide evenly into this one. 12, I would just, both 3 and 4 work. In this case, no. 13, prime number, I just divide it by 13, and does it go? 14, same way. Of course, you could also do 7 and 2. They both would have to be factors for 14 to work. 15, both 5 and 3 would have to work. When I hit 16, I would just divide it by 16. And in the case of 16, sorry about that, it does go evenly. It's going to go 23 times. Now, you hit a point, it's like, how do I know when to stop? Because you're going to hit a point where what you're dividing by, you get a smaller quotient. And then you know not to try anymore. And there's my list of 8 factors for 368. When you type these in, you don't have to type them in order. You'll separate them by a comma. Okay, so that's just finding factors of a number. And there's a couple of those to do. Now, just some terms about numbers: prime, composite, or neither. All right. A prime number is any number which only has 2 divisors, one in itself. But notice what I said there. It must have 2 divisors. That's why. So what is the first prime number? It would be 2. It has 2 divisors, 1 and 2, and that is it. 3 is the next prime number. It has only 2 divisors, 1 and 3. 1, by definition, then is not prime because it only has 1 divisor itself. So that is your one answer of neither. Otherwise, it is going to be prime or composite. A composite number has more than 2 divisors. So like 368 would be composite. All right, and then there's a few just prime or composite numbers. And now, next thing, see how many people remember maybe doing something like this, about 4th or 5th grade. Different than writing down the factors of a number. So here's the number I'm going to do, 1,269. Find its prime factorization. All right, so there is, I'm not going to write this all out. There is a theorem called the fundamental theorem of arithmetic. And it says this: any natural number can be broke down to a, well, I should cite for one. So let's say 2 or bigger. Any number, 2 or bigger, can be broke down to a product, which means multiplication of prime factors that is unique. Right? So there wouldn't be 2 answers, aside from the order at which you write the factors, which doesn't matter because multiplication is commutative. So this is the part to see if this rings bells, if you remember doing something like this. If I take that 1,269, I want to start finding numbers that divide into it evenly that are prime. I see that it's not what? It is not even. So I'm not going to bother dividing by 2, the first prime number. Let's check 3. Now, remember our divisibility test. 1 plus 2 is 3, 3 plus 6 is 9, and 9 plus 9 is 18, which is 18 is divisible by 3. So I know 3 will go in here. So I get my calculator out, and I'll say, how many times does it go? And I think it's going to go 47. Let's see here. I believe 47, but it may not be. So 1, 2, 8, 9, 6, 9. 6, 9 divided by 3 is 423. When I hit a prime factor, I circle it. Now I got 423. Not even. If I check 4 plus 2 is 6, plus 3 is 9. Okay, that's divisible by 3. So 423 divided by 9, or excuse me, by 6, by 3, goes 141 times. Got another prime factor. And then 141, 1 plus 4 is 5, plus 1 is 6. That's divisible by 3. So let's see how many times. 141 divided by 3 will go 47 times. Now, it turns out 47 is also prime. And that's when I know to stop. I broke it down as much as I can. So the prime factorization of 1,269, notice there's 1, 2, 3 factors of 3, and then that factor of 47, and that is its prime factorization. We call this a factor tree, which is usually, you don't have to do it this way. It's just kind of a visual way to help keep it organized and breaking it down to find its prime factorizations. And I think every kid that ever goes through 4th or 5th grade has to do factor trees. Does that ring bells doing a factor tree?
No.
Okay, well, fair enough. Does it make sense though how I did it?
Yeah.
Okay. All right. So there's going to be a couple problems just finding some prime factorizations. And all right. Another arithmetic concept. I'm going to turn the page. How much time do I have left? I got about 5 minutes. LCM stands for least common multiple. All right, so the least common multiple is, so I hear the term least, so I'm already thinking smallest. When I find the least common multiple, I want the smallest number of, say, 2 or even more numbers, but at least 2. I want the smallest number that both of those numbers will divide into evenly. The LCM, say LCM of 3 and 9. The smallest number that both 3 and 9 divide into evenly is 9. Okay. So concept of least common multiple. Now, let's do another one, maybe not so easy. LCM of 10 and 25. Okay. Now, how in the wide world of sports am I going to come up with this? Now, I can always do common multiple. That is, find a number that both of these divide into evenly really quick by just multiplying the two numbers together. 10 times 25 is 250. I'm guaranteed that both 10 and 25 will divide evenly into 250. But that's not the smallest one. The smallest one, it turns out, is 50. So what could be a way to come up with that number that is the smallest, that is systematic, that you're not kind of like, and how do you know you definitely got it? So, for one, this one, that's pretty quick and easy. But this one, it's a little bit more difficult. Find the prime factorization of each of these two numbers. And we're going to use the prime factorization of each of the two to come up with this. Prime factorization of 10 is 2 times 5. 25 is 5 squared. All right. The LCM will be the product of all the unique prime factors you see across the board, here and here, which is in this case 2 and 5. And then each factor raised to the highest power occurring in any one of them. Now, this has an exponent of 1. This one had an exponent of 2. And then you just multiply this out. That's going to be 5 squared is 25, and 2 times 25 is 50. Okay, so you can use prime factors to find these LCMs when it's a little bit more difficult. And there are a couple that you're going to definitely want to use some prime factorization with. And there's about 5 or 6 of those. And then that's it. That's as far as I want to go with this today. So what I'm going to do is I'm going to go ahead and assign the homework. So it'll be in whatever you see here in a little bit. I'm going to go in and just hit assign like I do in the 120. So there'll be 2 sections, 1.1b, it's got 10 problems, and 1.2, which has got about 21 problems. I'm going to hold off on assigning the quiz. I'm just going to assign these 2 homework assignments. This one will take a little bit longer than 1.1a that I assigned because of the least common multiple problems at the end. Those will take a little bit more time to do. So I'm going to go ahead and assign those right now. And I'm going to put the same due date on the 20th, which is that Sunday. And I'm going to assign the 1.2. All right. And which deals with the factors and prime factorization and finding LCMs. And so they are assigned. Stop share. I'm going to go ahead and pause this recording.